Now let's solve some questions related to the previous topic. So consider this question. The means of two samples. So analyze and then we'll write that too. So the means of two samples. So it is sample of sizes 1000 and 2000. So they are sample size. N1 is 1000 and N2 is 2000. Okay, respectively are 67.5. That means the means of samples are 67.5. That means x1 bar, the mean of sample with size 1000 is 67.5 and mean of the sample with size 2000 is 68. So that is given. Means of two samples of sizes 1000 and 2000 are 67.5 and 68. Now the question is, can the samples be regarded as drawn from the same population of standard deviation 2.5? So this 2.5 is sigma, means it says they are drawn from the same population of standard deviation 2.5. So here sigma 1 and sigma 2 are equal and that is equal to 2.5. Okay, so that is sigma 1 equal to sigma 2, which is equal to sigma that is given as 2.5. Okay, so now first of all, to test the hypothesis, we'll write the null hypothesis. Null hypothesis H0 mu1 equal to mu2 means you need to test whether there is any difference. So we are assuming they are equal. Okay, null hypothesis we are assuming that is the means are equal, mu1 equal to mu2. Therefore alternate hypothesis HA, that is mu1 is not equal to mu2. So for each step here you will have marks, so write the steps correctly. Now second one, we will calculate the statistic. Okay, so the test statistic Z is equal to, so I hope you remember the formula which we have written in the previous lesson. That is, here the standard deviations are equal. So we will use the formula, which one? X1 bar minus X2 bar divided by the standard error, and the formula for all the three cases are equal, but only the difference is the standard error formula. So here the standard error is given as sigma under root of 1 by n1 plus 1 by n2, because this is sigma 1 square upon n1 plus sigma 2 square upon n2, but sigma 1 and sigma 2 are equal. So I hope you remember that formula. So it is sigma into 1 by under root of 1 by n plus n1 plus 1 by n2. So just substitute the values now here. So sigma is 2.5 into under root of 1 by 1000 plus 1 by 2000, and on simplifying that you will get the value as 0.097. Okay, then Z is equal to x1 bar minus x2 bar upon that standard error S. So that is after substituting, that is 67.5 minus 68 divided by 0.097, which is given as 5.15. Okay, so we calculate modulus value, so it is positive 5.15. Then now we need to keep the level of significance, say alpha equal to say 1%, yeah, 5%, as you like. So 1%, if it is not given you can choose it of your own. So alpha is 1% I am taking here. Then the corresponding value of Z will be 2.5. 2.58 from the table which I had already given you. So alpha, Z alpha is 2.58. So now you can see here the calculated value, Z calculated value is 5.15. This is greater than the table value Z alpha. Okay, so what you will decide, that is the decision or conclusion will be therefore here H0 is rejected because calculated value is more than the table value, so it is rejected. Hence H0 is rejected means H0 we have taken that as the means are equal. So it is rejected means the means are not equal. Okay, so that is not equal, the means are not equal. Then what will be the conclusion? So the samples, therefore the samples cannot be regarded as drawn from same population, from the same population. Okay, so this is the way to test. Then now let's see another question. That is, again read the question properly. The average of marks scored by 32 boys, so that is 32 is say N1, N1 is 32, is 72 with standard deviation 8, while that of 36 girls is 70 with standard deviation 6. Now here it is given, that is N1 is 32 and N2 is 36, N2 equal to 36. Now and x1 bar is 72, that is the mean marks of the boys is 72, and x2 bar equal to 70, and here standard deviation of the boys, so this is S1 is given because sample, it is a sample, so S1 is given, that is 8, and S2 is given as 6. Okay, then test at 1% level of significance. So alpha is 1%, it is given, whether the boys perform better than the girls. So here null hypothesis, H0 you will take it as mu1 equal to mu2. Then alternate hypothesis, that is HA is mu1 not equal to mu2. Then now calculate the statistic. So test statistic, Z is equal to x1 bar minus x2 bar divided by standard error, where standard error is equal to, so which formula you will use, S1 square by N1 plus S2 square by N2. It's a clear question, that is the standard deviations are not same, or the population standard deviation is not given directly, everything is given here. So S1 square means 8 square by N1 32 plus S2 6 square by 36. Okay, so on calculating you will get this as square root of 3, under root of 3. Therefore Z will be, putting in this value, x1 bar minus x2 bar means 2, 72 minus 70 is 2 divided by root 3, you will get the answer as 1.15. Therefore modulus of Z, that means Z calculated value is 1.15. Then it is given alpha is 1%, therefore Z alpha from the table you have, it is 2.58. Now z calculated value is less than z table value. Therefore, what is the conclusion? We accept H0. We accept H0 means, what was your H0? H0 is mu1 equal to mu2. Mu1 equal to mu2 means, and we accept that one, means the means are same. The means are same means there is no difference between the performance of boys and girls. Okay, so we accept H0. Therefore, the boys do not perform better than the girls. So that is the conclusion. Okay, now let's do one more question. Sorry. Now that question, two groups consisting of 400 persons have mean 400 and 500 persons have mean heights. So two groups consisting of 400 and 500 people. So that is N1 is 400 and N2 is 500. Okay, have mean height. Mean height 68.5. So this is x1 bar 68.5 and x2 bar 66.1. That is a mean, and variance 6.4 and 6. So here also sample is given. So it is S1 is 6.4 and S2 is 6. Examine whether the difference is significant or not. Sorry, here variance is given, not standard deviation, variance. Variance is given means this is S1 square and this is S2 square, because square root of variance is standard deviation. Here variance is given. So S1 square is 6.4 and S2 square is 6. So we need to test whether difference is significant or not. So null hypothesis, as always, we'll take H0 mu1 equal to mu2, means we are assuming that is they are equal, they are same. Okay, then and alternate hypothesis will be HA mu1 not equal to mu2. Okay. Then second part, statistic, test statistic. That is Z is equal to x1 bar minus x2 bar divided by standard error, where the standard error is given as standard error. Which formula you will use? Here S1 square is given, S2 square is given, N1 is given, N2 is given, and here nothing is told about the population variance or population standard deviation. So we assume here they are not equal and they are unknown also. We don't know nothing about population variance. Okay, so here you will use the formula S1 square by N1, the case 3, plus S2 square by N2, where the same, sorry, here N S1 square by N1 and here N2. It's the same case. So standard error is S1 square by N1 plus S2 square by N2. So that is equal to under root of S1 square 6.4 divided by N1 400 plus 500 6 divided by 500. So that is equal to, on calculation you will get this is 0.016 plus 0.012. On further calculation you will get this as 0.16733. Okay, therefore mod of Z will be 2.4, means x1 bar minus x2 bar is 2.4 divided by this 0.1673. So on calculation you will get this as 14.34. Okay, so here now table value alpha is given as nothing. So what you will take? So here I will assume alpha is, say you can take it as 1% or you can take it as 5%. So I am taking it as a 1%. Therefore Z alpha is 2.58. Now therefore Z calculated value is greater than Z table value. Therefore we reject the hypothesis. Reject the hypothesis. What was our hypothesis? The means are same. Okay, so but we reject that one, means the means are not equal. Therefore the difference is not. So examine whether the difference is significant or not. That is what we wanted to see. Okay, so when you reject that hypothesis, the difference is, we have taken, they have same mean, we rejected that, means the difference is significance. The difference is significant. Okay,